Alright, so I'm going to show you one of the most important things in algebra that you can bring forward going through the rest of your math classes, and that is graphing equations on a coordinate plane. So first, I have to show you what a coordinate plane is, how it works. I'm pretty sure you know, but basically you have an x-axis and a y-axis. This is the x-axis, this is the y-axis. What this describes is an infinite number of points on a plane, and the location of any point is described by its x value and its y value. So if you have a point that's 1, 2, means it has an x value of 1 and a y value of 2. That was really weird what I just did there, but I don't care. A y value of 2. Okay? So to find that point, you would go 1 on the x-axis and then 2 on the y-axis. So this would be where the point is. Make sense? So that's pretty simple. Now we are going to graph an equation, and that's a little bit more challenging, but not that much challenging. So we have y equals 2x plus 3, all right? This is in slope-intercept form of an equation, which means that you have a slope, which is 2, and an intercept, which is 3. I'm going to get into both of those because those are both important to what's going on here. So the slope-intercept form of an equation is described by y equals mx plus b, where m is the slope of the line, right? Slope of the line, and b is the y-intercept. So what's a y-intercept, what's an x-intercept, and what's a slope, all right? I'm going to go through all those. So first of all, if you have any equation and you want to find what the intercepts are, first of all, what is an intercept? An intercept is a point that's on the x-axis or the y-axis. It's on the actual line, the y-axis or the x-axis. Following, an intercept has to have a value of 0 for the other axis. So, for example, if you want to find the y-intercept, the x value has to equal 0. Let me show you that. Basically, if you have a y-intercept, it means that it's a point anywhere on this y-axis, right? Anywhere on this y-axis. And how do you get a point on the y-axis? The x value has to be 0, because you're not 1, you're not -1, you're 0. You always have to be 0. Down here, x value is still 0. Even though the y value is changing, the x value is still 0. It's 0 throughout. So to find where a line intercepts the y-axis, all you have to do is set equal to 0, because once you do that, then you know that whatever point you get spit out at you is going to be on this line, because x equals 0, and this is the only place where x equals 0. It's on the y-axis, okay? So let's do it for this one. So y equals 2 times 0 plus 3. So y equals 0 plus 3, so y equals 3. So that means that the y-intercept would be at 3, so it'd be about here, whatever. All right, does that make sense? Now, if you have this equation here, and you know that it's in slope-intercept form, y equals mx plus b, b is always the y-intercept. That is the purpose of writing an equation like that, because you know that automatically if you set x equal to 0, b is going to be your y-intercept, right? That's how that works. So you don't really have to set x to 0 to find it. You can just say, oh, I have y equals mx plus b, so b is 3, so the y-intercept is 3. Now, let's find the x-intercept. That's a little bit more difficult, but basically you follow the same process. You have to set y equal to 0 to find the x-intercept. So you have 0 equals 2x plus 3. Then you subtract the 3 over, so negative 3 equals 2x, and negative divided by 2, negative 3 halves equals x, so the x-intercept would be around here. Okay? So if you do that, you have your line. You have these two intercepts, y at 3 and x at negative 3 halves, and all you do is connect them. Hooray, it's a line. Now, generally, you don't solve for the x-intercept and do this. It makes it a little more challenging, but what you usually do is you just look at this m value here, which is 2, okay? M is the slope. So once you have your y-intercept, which is 3 right here, okay, all you do to make your line is you realize that the slope of this is 2 over 1. And I'm sure you've heard that the slope equals rise over run. Have you heard that before? Or it's the change in y over the change in x. So what does that mean? It means that to get to the next point on this line from right here, right, you have to rise by 2 and you have to run by 1, okay? So let's do this. So I'm going to rise by 2, right? So this is like my ghost point, and then I'm going to run by 1 over here. See what I did there? I went up 2 and over 1. Rise, run. And then you connect them. Bam, and you're done. Now look, if you use this method, but you go the opposite way, right? Because if you subtract 2 and go left 1, right? Then you're basically doing the same thing but going the opposite way. Because to go forward, you have to rise and run. But to go backwards, you have to do the opposite. Because basically, okay, so you're at this point right here, right? At 0, 3. That's the y-intercept right here. Now, you want to go down by 2 and to the left by 1. And so that would be down by 2, so you would be at 1, and then to the left by 1, so that'd be here. See? See how that works? So, essentially, when you're going forward like this, you do rise over run. Make sense? And then you can reverse it by going left by 2 and down by 1 if you want to go the other way. Does that make sense? Because you would have to go up. You would have to go up 2 and over 1 to get to this point right here. See how that works? And another thing that's important to note is if the slope is positive, so if m is positive, it means that it's going to be increasing as you're going in the right direction, in the positive x-axis direction. So the actual line itself is getting higher and higher as you go this way. Does that make sense to you? All right.